Okay, let's look at L'Hopital's rule. Right? Remember that when you try to evaluate the limit, you basically plug in a number to see if you get a finite number. If you do get a finite number, that's the limit, right? But sometimes we get a case where you get a 0 over 0 or infinity over infinity, right? Those are called indeterminate forms where we can't really make any conclusion from there, so we have to do some work, right? So when those forms happens, there's a convenient rule called the L'Hopital's rule that we can apply to evaluate the limit, right? So it's probably easier to just look at a couple of examples, right? Here. Right, so let's look at this limit as x approaches 0, and the function is 3x plus 1 minus e to the 3x all over x squared. Right, so let's plug in the number 0. Right, so denominator 0 square, so this guy approaches 0. On top, you have 3 times 0 is 0, plus 1 minus e to the 0 is 1, so 1 minus 1. So numerator is actually 0. Alright, so when you have 0 over 0, we can actually take the derivative of the numerator and the derivative of the denominator separately, then evaluate the limit. So let's do that. So you have limit as x approaches 0. Derivative of 3x is 3, and derivative of 1 is 0. Right, derivative of negative e to the 3x is negative e to the 3x, right? Then multiplied by the derivative inside, so it's a chain rule, so it's going to be 3 in front, and divided by 2x. Derivative of x squared is 2x, right? Then plug in again, right? Then in this case, x goes to 0, so you have 2x is definitely going to 0. Right? Then here, 3 minus 3 times e to the 0 is going to be 3 minus 3. So again, we have numerator and the denominator going to 0. Alright, so there's no point of stopping, so we're applying L'Hopital's rule here. Right? We can apply another L'Hopital's rule. So L'Hopital's rule applied here. Right, so we still have the limit as x approaches 0. Right, derivative of 3 is 0. Right, derivative of negative 3 e to the 3x would be, let's see, negative. Right, derivative of e to the 3x is e to the 3x times 3, but this 3 was already there, so that will make it 9. Right, derivative of 2x is 2. Right, then plug in. Right, so as x approaches 0, we know that e to the 0 is going to be 1, so this is going to 1. So you see that you have negative 9 over 2 is what's left. So that is the limit. So negative 9 over 2. Right. So that's how you apply L'Hopital's rule. So whenever you have 0 over 0, when you plug in, you get to take the derivative of the numerator and the denominator separately and do it again, right? Until you get a number. Right, so let's look at another indeterminate form, infinity over infinity, right? So limit as x approaches negative infinity, 1 plus e to the negative x over 1 plus x squared. Right, so let's do that. So when you plug in, 1 plus negative infinity squared would be positive infinity plus 1, so it's going to be still positive infinity. So this guy goes to positive infinity. Right, 1 plus e to the negative infinity, so e to the infinity, of course e to the huge power is going to be huge, so it's going to positive infinity too. Alright, so if you get infinity over infinity, then we can just take the derivative of top and bottom. So applying L'Hopital's rule here. Right? So you have a limit x approaches negative infinity. Then derivative of that is 2x. Right, derivative on top, derivative 1 is 0. Derivative of e to the negative x is negative e to the negative x. Right, so let's do it again. Plug it in. So 2x is going to 2 times negative infinity, so it's going to be negative infinity. Right, and you have a e to the negative infinity, so e to the infinity. So this is going to still with a negative sign, so it's negative infinity, right? Sign doesn't really matter as long as you have infinity over infinity. We can still apply the L'Hopital's rule. So apply another L'Hopital's rule here, right? Then you have a limit x approaches negative infinity, right? And the derivative of 2x is 2. Right? Derivative of e to the negative x is e to the negative x times negative 1, but there's a negative 1 here, so it's a positive e to the negative x. Right? Then plug in. Alright, so in this case, on top you have e to the negative infinity, so this guy is going to go to positive infinity. Right? 2 is going to stay as 2. So infinity divided by 2 is still infinity. So in this case, limit doesn't exist because it's going to go to positive infinity. Right? Alright, so that's how you apply L'Hopital's rule. And there are a couple of indeterminate forms that we need to pay attention to. Alright, that's it. I hope that this was clear.